Today, let's dive into the factors affecting the composition of milk. For detailed notes, check the link in the description. Milk composition is influenced by several factors, including genetic, physiological, environmental, and management-related aspects. These factors determine variations in fat, protein, lactose, minerals, and vitamin content, impacting both nutritional value and processing characteristics. Species and breed differences. Different species have distinct milk compositions due to variations in metabolism, digestive efficiency, and genetic traits. For example, buffalo milk has higher fat and protein content than cow milk, while camel milk has lower fat and lactose but higher vitamin C. Among breeds within the same species, composition varies significantly. Jersey and Guernsey cows produce milk with higher fat and protein content than Holstein Friesian cows, which yield larger milk volumes with lower solids content. Stage of lactation. Colostrum, first few days postpartum, contains higher protein, including immunoglobulins, fat, and minerals but lower lactose. It provides passive immunity to the newborn. As lactation progresses, the fat and protein content decreases slightly, while lactose remains relatively stable. Late lactation milk, after peak yield, tends to have higher fat and protein due to a reduction in overall milk volume. Nutrition and feeding practices. Energy intake. A high-energy diet increases milk fat percentage, whereas energy deficiency leads to milk fat depression. Protein intake. Adequate dietary protein is essential for milk yield and casein synthesis. Low protein intake reduces milk protein content. Forage to concentrate ratio. High forage diets promote milk fat synthesis by enhancing rumen acetate production. High concentrate diets reduce milk fat content but may increase milk protein yield. Minerals and vitamins. Deficiencies in calcium, phosphorus, and vitamin A impact milk composition, reducing quality and yield. Milking frequency and management. More frequent milking, 3 to 4 times per day, increases overall milk yield but slightly lowers fat and protein percentages due to dilution. Infrequent milking, once a day, results in higher fat and protein concentration but lower total yield. Udder health and proper milking techniques prevent milk quality deterioration caused by incomplete milking or contamination. Parity. First lactation cows produce milk with lower fat and protein, but higher lactose compared to older cows. Multiparous cows, higher lactations, show higher fat and protein content due to improved mammary gland development. Seasonal variations. Summer. Increased heat stress leads to lower fat and protein content due to reduced feed intake and altered metabolism. Higher water consumption dilutes milk solids. Winter. Enhanced fat and protein levels occur due to better feed utilization and reduced metabolic stress. Increased roughage intake supports higher acetate production, enhancing milk fat synthesis. Environmental conditions and stress factors. Heat stress reduces feed intake and alters metabolic pathways, leading to lower fat, protein, and lactose content. High-altitude conditions can influence milk composition by modifying metabolic and respiratory functions. Poor housing conditions and inadequate ventilation negatively impact overall milk yield and composition. Mastitis and udder health, subclinical and clinical mastitis significantly alter milk composition by increasing somatic cell count, SCC, and reducing casein, lactose, and fat content. Infected milk has higher sodium and chloride content due to damage to the mammary epithelium. Antibiotic residues from mastitis treatment may interfere with milk processing and fermentation. Genetic selection and breeding programs. Genetic. Improvement programs enhance milk fat, protein, and casein content by selecting high-yielding breeds with superior lactation traits. Crossbreeding can lead to better milk solid percentages while maintaining overall productivity. Hormonal regulation and physiological factors. Prolactin and oxytocin play a vital role in milk secretion and letdown, influencing yield and composition. Insulin and growth hormone impact nutrient partitioning, affecting protein and fat synthesis. Pregnancy. During the late gestation period, milk fat and protein content increase, but milk yield declines due to hormonal shifts. When processing and handling conditions, pasteurization and heat treatments can alter milk protein structure and reduce vitamin C and B-complex vitamin levels. Homogenization reduces fat globule size, modifying fat digestion and sensory characteristics. Storage conditions impact milk stability, with prolonged storage leading to lipid oxidation and protein degradation. If you found this video informative, don't forget to like, share, and subscribe to the Food Tech for more insights into food science and technology. See you in the next video.